In today's video, we're going to continue our discussion of slope, and today we are focusing specifically on word problems and getting into deeper understanding what is the meaning of slope and the y-intercept when it comes to some of the graphs that do belong to real-world situations and word problems. So I'm going to zoom in on this first example, and so let me zoom in some more. So here we have how much snowfall was happening in New York during a certain amount of hours. So you are seeing in this picture, you are seeing that the snowfall seemed to be starting at a certain value already. So at 0 hours, make sure we understand this is your hours. At this time, at the beginning of the graph, this is how much snow was on the ground. Accumulation. This is how much it was there. So if we were to graph this, or I'm sorry, if we were to create an equation, we would say, well, this graph began at 4. Okay? So we would say 4 inches of snow was on the ground. So even before the snowfall started, there was already snow. So our next step is to determine the slope and the meaning of it. So this is a great example where your graph is not a standard graph that goes by 1, 2, 3, 4 on X and Y. It does go on X, go by 1, but on Y it goes by 2. Why is it important? When we determine the slope and our little values that we are working with, and this is not a perfect situation, so just kind of follow my lead in this particular scenario, but you are gonna do this. Okay, when you do that rise and a run, you are looking at, oh, there's just 1 unit by 1 unit, the slope is 1. However, this change is actually 2. From 4 to 6, the change, the rise was 2 over 1. 2 over 1, okay? So remember, this is your rise of 2, run of 1. So just a little bit of review here. And so what does it mean? There were 2 inches, so we're paying attention to our labels. Super important. Since we do have a real world situation, we're not going to just say, oh, it's 2 over 1, or it's 2. What does this mean? Snow falls 2 inches. I know you're hungry. Per hour. That's the meaning. So in your answer choices, you might have all of this scenario. Snow falls 1 inch per hour. Snow falls 1 inch for 2 hours. So they could play with these values and the meaning of them and twist and turn the meaning. All right, so for our equation, as you remember, we only have to fill in 2 values right here, 2 values, our AM and our B. And what are they? AM is 2 over 1, or you can write 2, and then B is 4. And here's your equation that represents this particular word problem. On to question number 2. All right, so as we progress to example number 2, I hope you've seen there's a difference in graph. Your values, your graph is decreasing. So we are observing a negative slope. So any of these rationale and analysis points you should be making at all times as if it was not necessarily a word problem. You always should, like, what can I tell? Is it proportional, non-proportional? What's going on with my graph? I have fallen values. Right away, then you are seeing that you're going to have a negative sign for your slope. Also, keep in mind, we talked about that this particular line is falling. Well, if it's falling, look at your y values. You were 300, 250, 200, and it's your values of y are decreasing. We can write this in our meaning as well to help with that interpretation. So what we have going on, we have water in a bathtub situation, and so what's happening, it's just draining. Okay, it started at 300 gallons. This is our V, beginning of our graph. This is the beginning of our graph. And we can see that every 2 seconds we have very good graph right here because it has different scale for your x-axis and different scale for your y-axis. So every 2 seconds they have been timing the change right here. Every 2 seconds we have less and less and less and less water. So y-intercept means at 0 seconds there was 300 gallons, or there were 300 gallons in the tub. That's a lot. 300 gallons in the tub. And so here's our rate of change. Let's take a look at it. I already did this little dots to help me with my analysis. And this is, again, we've seen, yes, when we are in our graph, it's decreasing 1 unit by 1 unit. However, the value of the unit is not 1. So here we went from 300 to 250, decrease of 50. Here the change is 2. So when you're writing out initially, yeah, you can say 50 over 2. We always have to reduce it as much as possible. 25 over 1. So decreasing of water or draining. Now you can kind of fine-tune your statement by 25 gallons per second. So in the interpretation, it's very important to note that we don't necessarily say negative 25 by 1. We are going to use the words that describe the negative change. So decrease, draining of water, reducing, subtracting, so if there's some kind of mathematical question and without too much explanation, withdrawing. So if it is a savings account and somebody is taking the money out, we would say they're withdrawing, and so on. All right, next example, example number 3, graph number 3. So this is our proportional graph. Let me zoom in. So that means the value of the beginning of the graph is 0, 0. Let's talk about what is this graph all about. Eliminate ingredients. So how many lemons and how much sugar. So the meaning of the 0 is very, very straightforward. No lemons, no sugar, no lemonade. Okay, this is an excellent real-life application of proportional relationship. To make a lemonade, you need to have both lemons and sugar. And so if you don't have these ingredients without each other, they're really not making a lemonade. Okay, so now we're going to take a look at our slope. And again, we have really nice graph that we're analyzing. I usually like to have several dots, several values that we can utilize. And once again, look at what is happening here, my friends. We have been utilizing this 1 over 1. We've seen the rise of 1, run of 1 several times here, or fall of 1. But the meaning of this 1 unit is not 1. The meaning is 30 in this situation by 10. Okay, 30 by 10. So here we can write it down just like it says. Then we're going to reduce it as much as possible. So the meaning would be, after we reduce it, would be 3 grams of sugar per lemon. Or you could have said here 30 grams of sugar per 10 lemons. Okay? But as you reduce it, you are making sure you are explaining this particular smallest, simplest ratio. And so from here, your graph will have an equation y equals 3x, which that made me recall that we did not write down the value or the equation for graph number 2. Let's go back to this one. So in this particular situation, I want to make sure that we are writing this down in the format that really is applicable to this word problem. We're going to actually do both. So in our equation, we would say, well, yeah, we need to enter a slope and y-intercept. So when we do so, we will have this look. However, in the word problems, you're going to start noticing that the more applicable interpretation of this graph would be in this format. 300 was the beginning value, and then there was a reduction of 25 gallon, reducing, draining, decrease of water of 25 gallon per second. So both of them are correct. We've seen both formats. Just want to make sure that you are comfortable with both and understanding that 25 over 1 is still a slope, 300 is still a y-intercept in either one of these formats. So back to the lemons, everything is very straightforward here, proportional graph. Just make sure you are paying attention to the scale of your graph to interpret the meaning. All right, and the last situation, love that we have this particular situation in our word problem. This is our example of what does zero slope in real life situation looks like. Okay, so we have Remy's bank account and the balance, how much money Remy has over several weeks. And so we do have a beginning of the graph. It began at 200, okay? So, and we literally would say $200 was the starting balance. Okay, makes perfect sense, yeah. However, we are seeing that as the weeks go, after 5 weeks, 10 weeks, 15, 20, 25 weeks, the value, the balance of Remy's account has not changed. So you might say, well, what is happening? Well, if this person put $200 in their bank account, they're not putting any more. The money is just sitting. There is no increase in value or decrease in value. Okay, so first of all, I want to make sure that you realize, and this is your zero slope. That means there's no rise. Yes, there is, not raise, rise, oh, cannot spell, rise. So there's no rising of the balance. There is run, you can track that, you can say over 5, over 10, and so on, but there's no change in the money balance. Okay, so you do not have increase in value. So we would say no money added over time. And your graph would be, your equation would be